Hello everyone, welcome back to PN&L channel where we create content with practical IT solutions. If our videos are helpful to you, kindly subscribe to this channel, click on the thumbs up button and let us know in the comment section what you would like to see. In this video, we will be installing and configuring the OpenStack Neutron on the compute nodes. So I have two compute nodes in my environment. The Neutron is the networking portion of the OpenStack, which allows instances to communicate with the outside world, and also we can use security groups to allow access from the external world to the um, to the compute nodes. So without further ado, let us dive in. So the first thing we're going to do is we're going to install the Neutron Openvswitch agent on the two compute nodes. So we're going to, the next thing after this is completed is we're going to um, configure the common components of the Neutron. So the common component configuration includes the authentication mechanism and message queue and also the plugin. So in order to do this, we're going to edit the neutron.conf file, but before we do that, we're going to comment out the database portion of the neutron.conf file on the compute nodes the because Neutron does not directly access the backend database, or the compute node doesn't directly access the database. So as you can see here, we've commented out the SQLite portion. Okay, but before we continue, we have to ensure that we have this nets.ip4.conf filter. We need to ensure that they are configured, because as we mentioned earlier, it allows the compute node to be able to access the virtual IP or virtual host name. So next we're going to configure the neutron.conf file. So the first thing is we're going to ensure that we have the service plugin and the authentication strategy. So we first of all look for the okay 35. Next we look for the authentication strategy, which is Keystone. Okay, next we are going to configure the transport URL. which is the RabbitMQ. And also now we're going to configure the RPC response time, which is 180 seconds. Response timeout. So it's the seconds to wait for before the call times out. Next, we're going to configure the keystone authentication parameters. This is used, as we mentioned earlier, it is used to communicate with keystone, which is what authenticates every single communication between the services in OpenStack. So we're looking for keystone. Okay, next we're going to add the log path to Oslo concurrency. It enables or disables interprocess locks. So we create a temp file that stores the information for the locks. So next we're going to configure the networking components, there are two types of networking options in OpenStack. There is the provider service, and then there is the self-service networks. I will not go into the details of how of what that means. We can always read that up on the OpenStack website. And for this self-service network, we are going to be configuring the Openvswitch agent. There are three types of self-service networks. There is the OVN, there is the Openvswitch agent, and then there is the Linux bridge. I think the Linux bridge has been deprecated, so it's either we use the Openvswitch agent or we use the OVN type. So the Openvswitch agent builds on layer 2, which is the bridging and switching, virtual networking, which is the OpenvSwitch agent builds on layer 2, virtual networking infrastructure for instances, and it also handles the security groups as well. As we mentioned, the security groups allows the configuration of firewall parameters to allow or disallow communication between the instances and the external world. So here, what we're going to do is we're going to be configuring the Openvswitch agent in the plugins directory of the Neutron file. We're going to do that on both compute node. In the OVS section, we will map the provider virtual network to the provider physical bridge, and then configure the IP address of the physical network interface that handles the overlay network. Because we're in a high availability environment, we're going to be using the virtual IP. That's what we're going to be using to interface between the overlay networks and the external networks. So we're going to go into the OVS portion, and we're going to look for bridge mapping. Let's see. So first we're going to be doing, we have the local IP. I saw the local IP just now. Okay, there we are. So we're going to add the local IP, which is the virtual IP. Okay. Next, we're going to add the bridge mapping. We configured this in the previous video where we configured Neutron for the controller nodes. So we're going to be doing the same thing here. Okay, bridge underscore. Okay, there we are. And we have to ensure that this is under the OVS section. So let's go up, and we just configure that, and we're sure that it's under the OVS section. So save that. So as you can see, we're using external as the provider bridge, and also, should I say, we map this external to the physical network, and then we also have a bridge that is also mapped to the external. We'll see how that works shortly. So we exit this. So next we're going to ensure that the provider bridge name is created and the provider interface name is added to that bridge on all compute nodes. So we're going to do that now. So first we're going to add the provider bridge name, which is BRETH1. Going to do the same thing for the second controller. So what we're going to do next is we're going to now add the ports, the provider bridge name that we created earlier on. We're going to match it to the physical interface. If you look at this here, we can see that the ETH2 is what we are going to use to connect to the Ceph storage backend, and ETH1 here, as you can see, is what we're using for the bridge and the physical interface to map the bridge name and the provider interface as well. So the ETH0 is what we configured as the management network. So next we're going to now add that, run this OVS VSCTL to add that. So next we go back to the Openvswitch.com agent.ini file. We're going to go under the agent. We're going to look for the tunnel types. The tunnel types where you're going to be configuring is VXLAN. So VXLAN is popular for allowing more than the 4096 default number of VLANs that can be created. We're going to be looking for L2 population. We're going to configure that to be true. Do the same for the next. We're going to enable the security group as we defined earlier on. And we're going to enable security groups first. And then we are going to add the firewall driver, which is Openvswitch. Okay, so the next thing we're going to do is we're going to check for cctl-p, and we're going to ensure that these two here are configured on all the compute nodes. So we can see here that this is correct. We save the file here as well, and we can see that it's configured. So let us clear that. So to enable networking bridge support, typically the BR_net filter kernel modules needs to be loaded. So it varies from operating system to operating system. So I'm using Ubuntu. I'm using Ubuntu 24.04, I believe. So next we're now going to add the Neutron authentication parameters to the nova.conf, because the reason for this is so that we can allow Neutron to be able to access the compute service, which is Nova in OpenStack. So we look for Neutron, and then we do the same thing for this one. Save the file, and then what we are going to do is we're now going to link the ml2 conf.init to the plugin file on both compute nodes. So finally we're going to restart the compute node, the Nova compute service on the compute nodes, and also we're going to restart the Neutron agent as well. Okay, all is good. So we do a status Nova compute, all good. we check the status on the second compute node. All good. Next, we're going to restart the Neutron. Oh, sorry. Neutron Openvswitch service status. We're going to check the status. We are all good. We're going to check the same on the second compute node. Okay, looks like something went wrong here. Okay, no, nothing went wrong. It's all good. Okay, so something different up here. Let us be sure. Okay, all good. So next, we're going to now check the controller node. We're going to run the OpenStack network agent lists to be sure that we have everything configured. Okay, so I noticed that there was some error in the Openvswitch agent file. As you can see, the error here, it says the Neutron plugin drivers for Openvswitch agent tunnel can't be enabled with invalid local IP. So I assume that we're going to be configuring the virtual IP just as we configured on the controller node. So I had to change that to the local IP, which is, if we look at this, if config, as you can see, is 192.168.80.124. So if we go to the file here, we'll see that the local IP has been configured properly. And also the same thing on the first compute node. So now what we're going to do is we're now going to run the Openvswitch, sorry, the Neutron agent list. So if we run the OpenStack network agent list, we should be able to see the entry for the compute nodes. Okay, as you can see here, we can now find the compute 00, which is not Open Neutron vSwitch agent, and then this is the one for the compute node 01, and you can see it's alive and the state is up, so we're good to go. I hope this video is informative for you. I'm looking forward to seeing you in the next video. In the next video, we're going to be configuring OpenStack Horizon, which is the dashboard. I hope all goes well, and thank you for watching. See you in the next video. Bye bye.